Welcome, my dear students. So, in this lecture series, I am going to give you some of the important concepts regarding the JEE Advanced topic on capacitor. So, this is purely based on the advanced exam. So, this is not in your JEE main syllabus. So, here what I have done, basically I have connected three different capacitors. So, that's why the problem name is three capacitor connection. So, I have connected three capacitors which are initially fully charged. Yeah. So one is 2 microfarad, another is 2 microfarad. These are the different capacitors that are initially charged, and now they are connected. Now you close the switch. Now you are asked to calculate how much amount of charge is being flown or what is the heat in that particular situation. So what you have to do, initially you give the charge to the plate whenever they are fully charged. So initially the 2 microfarad capacitor is uncharged. So it is plus minus 0 volt, means on this plate there is 0 charge, on this plate also there is 0 charge. Now for the second capacitor there is 10 volt potential difference and 2 microfarad is the capacitance. So can I write plus 20 over here and minus 20 over here, microcoulomb charge. Similarly plus 5 and minus 5. So please write the initial charge distribution. Now you assume that some amount of charge is being flowing from the capacitor. Let us say the Q charge has been flown from this. Okay. So Q charge is being flown. So that means what you can understand that for the second phase, whenever the charge is being flowing, so now the charge left on this plate is 20 minus Q. On this plate we add charge plus Q. Then on this plate we are taking out charge minus Q. Okay. Then again I am depositing charge on the 5 plate. It is 5 plus Q. Similarly, here it is minus 5 minus Q, and then again minus 20 plus Q. Okay, so these are the charge distribution after the connection of the capacitor. Now you have to write the net potential drop. So if I move along a loop, like this way, so inside the capacitor I am moving, let us say from this direction to this direction, then I am moving to this direction. Okay, so whenever I am moving towards the 2 microfarad capacitor, so I am moving from positive to negative end. So let us say the potential drop is over here is V1, then V2, then V3. Okay, so if I write the potential difference equation from the V1 part, so I am moving from positive to negative, so potential is being dropped, so minus V1. Then from V2, again I am moving from positive to negative, so this is minus V2. And then again for the V3 part I am moving from negative to positive, this means plus V. That should be equal to 0. So this is the potential equation for the 3 capacitor plot. So now I have to, let us say, or I can write it as V3 equals to V1 plus V2. Yeah, this is the potential difference equation. Now V3 is what? V3 is the potential difference across the third capacitor, that is this capacitor. So whenever I am writing C equals to Q by V, that is the basic equation for the capacitance for the parallel plate capacitor. So for that I should write the Q, that is the Q should be the charge on the positive plate. This is the concept that you should write the charge on the positive plate. So what is the charge on the positive plate for the V3? So V3 charge on the positive plate is 20 minus. So I am writing 20 minus Q divided by, so C is how much? C is for this is 2. That is the V3 value. That should be equals to V1 plus V2. Because to V1 means charge on the positive plate is Q. So Q divided by 2 plus V2 is how much? V2 is the charge on the positive plate is 5 plus Q divided by 1. Okay. So that will be the potential difference equation, and from that I write the charge equation. So if I solve this, so I am getting the value of Q should be equal to 2.5 microfarad. Okay. So this is the charge that has been flown through the entire capacitor. So if the charge is being flowing through the capacitor, so that is our answer, that how much amount of charge is being flowing. And once I know the value of small q, now I can write what is the charge left on each and every plate of the capacitor. Now similarly, once I know this value of Q, so I write the H, that is the heat flown, that should be equal to Q square by 2 C equivalent. That is the final answer. Now what is C equivalent? C equivalent is nothing but the equivalent of the systems. Now here the three capacitors of 2, 2 and 1 are arranged in series. So this 2 microfarad and this 2 microfarad will give the 1 microfarad, and this 2 1 and 1 finally will give the 0.5. So here C equivalent is our 0.5 microfarad. So if I put these two value, so that is 2.5 whole square here by 2 into 0.5 means ultimately what we got 2.5 whole square means 6.25 microjoule. So that is the amount of heat flown through this system. Okay. So this is another trick to calculate the H number. So H is what? H is the total heat that is flowing after the connection is being made. So once I made the connection, first you calculate the Q number. So that is the charge that has been flowing to the circuit. Okay. And once you got that Q number, so take the help of Q square by 2 C equivalent formula to calculate the H number for the system. Now, that will be your then answer. Okay. Hope you understand this. Now, moving on to the next situation. Let us say I am doing the same situation. Now, all the plates are charged. So, I can do it in the similar way. First of all, identify the charge given initially. So, initially, this plate is again 10. This plate is minus 10. This plate is plus 10. This plate is minus 10. This plate is plus 40. And this plate is minus 40. Okay. Now, assume the charge is flowing. Now, in any direction, you can take the charge. Okay. In any direction, you can take the charge. That is not affecting your answer. Only thing is that you have to write the potential equation properly. So, if I write the Q amount of charge is being flowing from the 40 plate, so here the charge left is 40 minus Q. Okay. Now, here the charge will be 10 plus Q. Then it should be minus 10 minus Q. Then it should be 10 plus Q. Then it should be again minus 10 minus Q. Then again I am adding the Q amount of charge which is minus 40. So, it should be minus 40 plus. Okay. So, once you assume the direction of the charge flow, next task is to write the charge left on each and every plate. Just once I write this, so I am getting the new type of distribution. Now, again you have to do the same situation. That means you have to move from where to here. Let us say one potential drop, then another potential drop, then again another potential drop. So, I am moving along a loop. So, V1, then V2, then V3. Okay. Now, V1, for the V1, I am moving from positive to negative. Positive to negative plate. So, potential is being dropped. So, minus V1. Then I am moving from again positive to negative plate for the V2. So, again minus V2. Okay. And again moving from negative to positive plate for the V3. So, plus V3, that should be equals to 0. So, finally, again rearranging this, I can write V3 should be equals to V1 plus V2. Again, mind it that once I write the potential difference, so that means V should be equals to Q by C, where Q should be the charge on the positive plate. Only thing you have to consider over here is the charge that is there on the positive plate. Okay. So, now V3 is this number. So, V3 is charge on the positive plate is 40 minus Q. So, divided by capacitance Q equals to V1 is the charge on the positive plate on the first capacitor, that is 10 plus Q. So, 10 plus Q divided by 1. Then V2 is the again charge on the positive plate, that is 10 plus Q divided by 2. Okay. So, if I solve this number, so ultimately I am getting again the Q answer is equals to 2.5 microjoule. That doesn't mean that every time I am getting the same answer, but values are such that I am getting the same answer here also. Q is 2.5 microcoulomb. That means this amount of charge is being flowing from for the system. So, once I close this switch, then the charge will be flowing within the capacitor plates, and ultimately this is the amount of charge that has been flowing. So, again I can write the H number. H equals to Q square by 2 C equivalent. Now, what is the C equivalent over in this situation? Here, there are 2 and 2. So, 2 and 2 give 1, and 1 and 1 again give 0.5. Okay. Again and again give another 0.5. So, it is basically C equivalent is again 0.5 microfarad. Okay. So, that means the answer remains same. That is Q square by 2C means 2.5 whole square divided by 2 into 0.5. That means 6.25 microjoule. Okay. So, this is the idea of solving this type of problem. Whenever there are 3 capacitors are given, or more than 3 capacitors may also be solved in this manner. Only thing is that you have to write the potential equation properly. And once you are writing the potential equation, make sure that every time you are taking the value of the charge which is on the positive plate. Okay. Now let us say this type of situation happens. Now the capacitors are there as well as the batteries are there. Once I use this particular system, that means this is a similar type of situation that we have already discussed in the electricity part where you do the circuit analysis. So this is the same situation here also. Okay. Only thing is that you have to write again the potential equation. So I know that to write the potential equation or the nodal equation, so you should give the potential. So for this 10-volt battery, so let us say this is a 0 volt. So here also 0, here also 0. For this 0, here becomes 10. For this 0, here becomes 4. Now only thing is that we are stuck with this potential. So let us say x is the potential at the nodal point. So once I write the x as the nodal point potential, then we have to assume that x is the high potential. Always assume that x is the high potential side. Now what is the potential difference between these 2 points across the 2 microfarad? Can I say x minus 10? Yes. X minus 10. So now corresponding to this x point, nodal point, I identify there are 3 different plates which are connected with this x point. So this system is known as the isolated plate system. Every time you have to identify this isolated plate system like the combination of these 3 or 4 plates, whatever the number of plates are there with that common x point. So this is known as the isolated plate system. What is that? So in isolated plate system, similar to the concept of Kirchhoff current law, that is KCL or junction law, you have to apply the conservation of charge. What I am saying that, let us say Q1 is the charge on this plate. Let us say Q1 is the charge on this plate, Q2 is the charge on this plate, and Q3 is the charge on this plate. So for the x point, I write the nodal equation as summation of Q1 plus Q2 plus Q3, that should be equal to 0. Why? Because charge can never be accumulated. So total charge on this isolated plate system must be equal to 0. So Q1 plus Q2 plus Q3, that number becomes 0. That is called basically the equation for the isolated plate system. So every time whenever you stuck on a particular point, so you have to apply the nodal equation, and for that you have to put the unknown potential, and accordingly you write the charge equation, that is Q1 plus Q2 plus Q3 equals to 0. So that equation will change depending on the number of plates connected with the point x. So once I write this equation, now in order to write the Q1, I have to write what? So we know that C equals to Q by V. So Q equals to what? Basically Q equals to C into V. That is the idea. Now what is V? V is the potential difference. So whenever I am writing the potential difference, every time I should assume that x is the high potential. So potential difference between this plate is how much? X minus 10. So can I write x minus 10 into 2 is the charge on the Q1. Similarly, potential difference for the next 2 microfarad is x minus 0 into 2. So 2 into x minus 0 plus last one is again 2 into x minus 4. 2 into x minus 4. That is equal to 0. So this is the nodal equation that I have written corresponding to the point x. So once I solve this, I can get the value of x. So what is the x number? So all 2's will cancel out. So I can write 3/8 should be equals to 10 plus 4 means 14. X becomes 14 by 3. So once you write the x number, that is the 14 by 3 potential at point x, now you know what is the potential difference between the 2 microfarad, between these 2 microfarad, between other 2 microfarad. Now I can write all the charge. Okay. So all the charge can be written. So now, so you are asked to calculate what is the charge on the capacitor plate. So Q1 should be how much? Q1. So once you write the x number, so clearly it has been known that the x is 14 by 3, that is less than 10. Okay. So if it is less than 10, so I can say this plate is acting as a positive plate, this plate is acting as a negative plate. Now between x and 0, x is the high potential. So this is positive plate, this is the negative plate. Between x and 4, so 14 by 3 is greater than 4. 14 by 3 number is greater than 4. So that plate is positive plate, that plate is negative plate. Okay. So this is how you can write the charge on the each plate. So regarding the Q1 number, what I can write? Q1 should be how much? 2 into x minus 10. That is the charge. Similarly, Q2 should be how much? Q2 should be 2 into x minus 0. And Q3 should be equal to how much? Q3 should be equal to 2 into x minus 1. So once you calculate the x number, that means these all the numbers can be calculated. Okay, so charge on each and every plate is known to us. Okay, so this is how you have to solve this type of problem. So same concept we have already applied in the current electricity chapter, where you solve this type of problem using the resistances. Now, instead of resistances, the capacitors will come into the picture, and accordingly, you have to solve the problem. Hope you understand this. Thanks for watching my video. If you like, please subscribe my YouTube channel. Bye.